Hello everyone, welcome back to Digital Dynamo Lab. In today's video, we are going to learn about the types of operating systems in a very simple way. So let's get started. Let's start with the first type, the batch operating system. In this system, the user does not interact with the computer directly. Earlier, users would prepare their work on offline devices like punch cards or paper tapes. After that, they would submit their jobs to the computer operator. The operator would then collect similar jobs that need the same resources and group them into batches. Once the batch is ready, the CPU processes one batch at a time. There is no direct input from the user during execution. However, one major drawback is that the CPU often stays idle, especially when a job is waiting for input or output. Batch operating systems were commonly used in places like payroll processing and bank statement generation. Now let's look at the time sharing operating system. In this system, each task is given a small time slot to run. This time slot is called a time quantum. Many users can use the same computer at the same time. Each user gets a turn to the CPU for a short period. That's why this system is also known as a multitasking system. When one task finishes its time interval, the operating system quickly switches to the next task. This switching happens so fast that it looks like all tasks are running at the same time. In this way, every task gets an equal chance to use the CPU. One of the big advantages is that CPU idle time is reduced, which improves efficiency. Some common examples of time sharing operating system are Multics and Unix. Next, we have the distributed operating system. In this type of operating system, multiple processors are used to handle work for multiple users and real-time applications. Instead of one system doing all the work, the tasks are divided and distributed among different processors. These processors can be located in different places, but they communicate with each other through communication lines or a network. Because the work is shared, the system becomes faster, more reliable and efficient. A common example of a distributed operating system is Locus. A network operating system is software that runs on a server to manage resources and services for multiple computers in a network. The server is a powerful computer capable of managing data, users, groups, security settings, applications, and other networking functions. It acts like a manager, making sure resources are shared efficiently and safely. The main function of a network operating system is to allow shared access to files and printers among multiple computers in a network, such a local area network or LAN or a private network. Some popular examples of network operating systems include Microsoft Windows Server 2003, Unix, Linux, Mac OS X, and Novell NetWare. In summary, a network operating system helps all the computers in a network together by managing resources, security, and applications from a central server. Another important type is real-time operating system, also called RTOS. This type of operating system is used when tasks must be completed within a specific time limit. Real-time operating systems are mainly divided into two types: hard real-time systems and soft real-time systems. A real-time operating system or RTOS is a system where the time required to process inputs and respond is very small. It ensures that critical tasks are executed on time. Response time refers to the time taken by the system to react to an input and display the updated information. In an RTOS, this time is very short, so the system responds almost immediately. There are two main types of RTOS: hard real-time systems and soft real-time systems. Hard real-time systems guarantee that critical tasks are completed on time. The response time is fixed, and missing a deadline can lead to serious consequences. For example, a pacemaker must respond within a fixed time to regulate the heartbeat. Soft real-time systems, on the other hand, are more flexible. The timing requirement is not very strict and small delays are acceptable. For instance, in video streaming, a tiny delay in displaying a frame does not cause major problems. In summary, both types of RTOS respond quickly, but hard real-time systems have strict deadlines, while soft real-time systems allow small tolerances. Thank you for listening.